Hi, everyone. My name is Deepak Dayama. I'm a product manager in the Container Services team. I'm joined today by Arya and Gad from KPMG. First of all, thank you for attending this session at this time of the day. We truly have the container faithful here. So it's awesome to be here after a year. We launched AWS Fargate at last reInvent, and several of our customers have adopted it. And in this session, we will share from a service perspective, what are some of the best practices as we see them when you manage your environments for deployment, how to do it safely, how to maintain isolation. And then we look at what KPMG has built with Fargate for their customers. This is a 300-level session. So the assumption here is you know what containers are, you know what ECS is and Fargate is, even if you may not have played around with it. Otherwise, a lot of the content that we go through may not make sense. So a couple of related breakouts. Actually, the first one is happening right now in about an hour. So if someone wants to run to that one instead, I wouldn't mind. And then we have another one which dives deeper into how to do debugging for and have visibility into your applications when you deploy onto Fargate. Especially important as you think about the level of abstraction that Fargate provides. So this is our agenda today. We'll quickly go over Fargate, how it fits into the container service offerings at AWS. What are some of the key primitives you should understand before we dive deeper into managing multiple environments with AWS Fargate, and some of the best practices. And then we go into the KPMG use cases here. So here is a quick overview of the container services landscape at Amazon. At the orchestration layer or container management layer, we have two offerings. One is Amazon ECS, built ground up in Amazon. It's a multi-tenant control plane which manages containers for you across your EC2 instances and now Fargate as well. And as of last reInvent, we also announced a preview of Amazon EKS, which has now gone GA, which is the Kubernetes offering from AWS. At the hosting layer, you still have to run these containers somewhere. You can manage them at scale using the Amazon ECS or EKS, but you need to run them somewhere. That somewhere is either EC2 that you manage yourself, or you just run them on Fargate, which is serverless containers. And lastly, you need to store those images somewhere so that you can deploy across the different services that you plan to deploy on. And that's with Amazon ECR. So before container management, you had to run containers across your instances, but there's a bunch of software you need to run along with it to be able to support your containers. So in this case, the orange boxes that you see are tasks. Tasks are essentially groups of containers which embody your application. But on top of that, you had to run your EC2 instances. You had to pick the right size of EC2 instances, and you had to manage the operating system, the Docker daemon, because you're running Docker containers, and also an agent if you're running ECS. ECS made it easy to run these at scale, build large clusters, launch thousands of containers on it. It managed, from a cluster perspective, the cluster health, which are the instances that are registered, and where can I place these containers using the placement engine with advanced placement strategies. But you still had these layers of management. So with Fargate, now you do not have to worry about launching your containers on EC2 instances. You do not have to worry about patching, updating, managing enough headroom in terms of capacity when you want to launch your containers. It's simply an API to launch your containers on demand. AWS manages all the underlying infrastructure for you. So as you see over here in the previous diagram, Fargate is the underlying layer, so it does not expose new primitives in itself. It does not create new endpoints. You do not have to learn yet another thing to be able to launch your serverless containers. The primitives that you use are ECS primitives. So for the rest of this talk, we will be referring to these primitives. So let's get acquainted with them so that it makes sense. The ECS primitives apply to both Fargate and the EC2 that you used to run before Fargate as well. The first is task definition. This is how I define my application. A task definition specifies what are the number of containers, up to 10 is what you can have, number of containers I'm going to have in this, where are those images that I'm going to pull for them, what is the networking going to look like for those containers, what are the ports I'm going to expose, and what is the size of these containers, or the size of the task itself. So you define your application, but these applications need to run within a certain boundary, and that is called a cluster. A cluster used to represent both a capacity as well as an administrative boundary. With Fargate, that changes. We'll talk about that a little bit later. But within that cluster, you run all your applications. They can either run as a standalone task, just like you run just an EC2 VM, you just run it. But that task is you have to manage it. You have to manage its uptime. If you just want to launch a number of tasks and not worry about managing for its availability, you can run it as a service. It creates replicas of the task, and it can be fronted by a load balancer, and you can have and ECS takes care of making sure we run the desired number of tasks that you have specified and spawn new tasks when the time is to scale or scale down. So these are the constructs. So now you can run Fargate without having to modify your task definition, which means within ECS console itself, this is the decision you have to make. Do I launch? I want to define my application. Will I want to launch it on EC2 instances, or do I just launch them on Fargate? As you see in the command below here, basically I've given a run task command, and only at the time of launching, I'm saying, well, launch it as a type of Fargate. I could have taken the same application, run it on EC2 instead. So it's great. You get serverless containers. You do not have to worry about patching. Can I just run every application that I have on Fargate, or do I have to make an either-or decision for all applications within that particular cluster? The answer is actually, it really depends on what assumptions your application is making on the underlying infrastructure. You may not be able to run all applications on Fargate, at least today. Here are some examples. This is not an exhaustive list by any means, but if you're going to use GPUs, that's not available on Fargate today. If you're going to run Windows native containers, you can run .NET Core, but if you're going to run Windows native, you cannot run them on Fargate today. ECS provides a great integration with EC2 Spot Fleet, but that's available only with EC2 launch type. There's no Fargate Spot at this point. Again, if you care about certain specificity around instances, you care about an instruction set that is only available on a certain instance, you should look at using EC2 instances for those applications. Because Fargate manages the underlying infrastructure for you for all your servers, there's a separation of responsibility, where AWS manages the underlying infrastructure. And therefore, there cannot be any privilege given to the containers. So no privileged containers. Daemon sets are sort of obsolete because daemon sets assume that it is a set of nodes that need to run. When you run your applications on Fargate, there's no concept of a node. There's just your application. There's just your task. Okay. So the answer is to the question I raised earlier around whether it's an either-or decision for all of my applications. The answer is you can actually run them in the same administrative boundary within the same ECS cluster side by side. So let's just say I have multiple applications for my business, and I want to run them across 3 availability zones as a best practice for high availability. They are 3 different subnets in the same VPC, and I have these applications. But my notifications application is not ready to move to Fargate yet because it uses EBS, and Fargate does not support EBS yet. So, but at the same time, you can still run your web and shopping application as Fargate launch type, and you can run your notifications applications on your EC2 launch type. They will run in the same cluster boundary, in the same subnets, and the same VPC that you own. So it's not really what we call a one-way door, where if you choose to migrate your application to Fargate or run it on Fargate first because it was easy, and now you realize, I have certain assumptions on instances that I want to run it on, and I want to move it back to EC2, you can totally do that without really compromising on sort of your location of the service and how it affects the rest of the services that you may be running in your cluster and your VPC. But as far as Fargate is concerned, the cluster is only an administrative boundary. There's no capacity associated with your cluster anymore unless you're running EC2 and Fargate side by side. You define the ECS cluster the same way. And this is important because you want to be able to have different environments here. So let's talk about how you enforce different kinds of permissions, especially when you have different environments and different applications to manage. So the first level of permission is what we call cluster permission. Cluster permission determines who can run, see tasks or services or perform certain describe actions within this particular cluster. The second is application permission. It's the role under which the application runs, the Fargate tasks run, and it determines what kind of AWS resources it is allowed to access. For example, only the payment app can write to a DynamoDB table, right? So you run it under a specific role which has access to that particular table, right? And lastly, there's a bunch of magic that needs to happen under the covers for Fargate for it to be seamless for you from a serverless containers perspective. But we make it explicit through a policy, and you run it under what we call a task execution role. This is when Fargate does an image pull for you, or it needs to send your application logs to CloudWatch logs in your own account. We need to send those logs to your account, so you need to give us permissions for us to be able to do that. And also, we need permissions from a networking perspective to provision your networking interface, deprovision them, and so on. So now you've set up your cluster permissions. So you can actually have a separation between your environments. Let's just say here I have a prod and beta clusters. For all my developers, I've given, they can spin up as many dev clusters as they want. ECS clusters are nothing but an administrative boundary. There's no control plane that you have to run separately. And then there's a QA cluster. But I have hired some contractors to do QA for me in the QA cluster. I do not want them to describe or do anything on my prod or beta clusters. So you can enforce your boundary at the cluster level itself. So another aspect of managing these multiple environments we covered compute. From a compute perspective, by the way, within your cluster, your tasks do not share the underlying kernel, for example, with other tasks. So you have complete separation even among applications within the same cluster as you sort of design your cluster and the applications that need to run within it. So the other aspect is networking, which is equally important. So there are different aspects here. First is at the task level, how does networking work for my applications? Just because you have opted into Fargate and you're letting AWS take care of the underlying infrastructure does not mean you give up control of the networking, right? So we still have a dedicated ENI for each Fargate task. The Fargate tasks run only in your VPCs and in the subnets that you designate to us. You have full control of the network access. You can apply your security groups just like you do for any ENI with EC2 today, and it has public IP support. So you really get a native VPC behavior between both your Fargate tasks, your EC2 instances. You do not really have to think about, well, how is my subnet routing going to work, or how is my NACL going to work, for example. And at the service level, the way you want to, doing multi-availability zone deployment is, if you want to do that as a best practice, you want to map, you want to actually specify the subnets you want to run the Fargate service in. And just by that, you actually achieve a multi-AZ deployment. Now at the cluster level, from a separation of your different environments perspective, we do not enforce or even define at the cluster level that this cluster has to map to a particular VPC. But we do recommend that you try to map a particular cluster, especially like a dev environment, to its own VPC or at least its own CIDR range. You do not want fate sharing between your different environments just because someone's application scaled too much, which was not yours, or it was in a different cluster, and suddenly you're out of IP space, or someone changed the configuration for the internet gateway or subnet routing, and suddenly you're having unknown issues now. So definitely consider at least doing a VPC to cluster mapping, or maybe at least a CIDR range. So we talked about how networking works at the task level, at service level, but how do my applications in these different environments talk to each other? So we have earlier this year launched service discovery. What service discovery enables you to do is to maintain the same code across different environments, and your services can address using a friendly CNAME, and it is built on Route 53 auto naming. So this is two services, highly available AWS services like ECS and Route 53. So you get a managed experience which is highly available, and there are no boundaries as such with respect to how you can do your auto discovery. If you want to do it across multiple environments, you're welcome to do that. But the key is that your applications can remain unchanged across these different environments. We have, as part of the service discovery offering, created Route 53 APIs for the creation of the namespace, first of all, and the CNAME creation for your services. The ECS scheduler on its end, what it does is whenever a new task comes up, it registers with the service discovery service as a potential backend, which can now accept traffic once it's healthy, and it registers a task IP and port. So now we've talked about networking. Let's talk about a concept which is specific to Fargate. Everything we discussed so far applies to EC2 launch type, Fargate launch type. In case of Fargate specifically, we have a notion of platform versions. Right now, we have 3 platform versions that are shipping today. The way we look at platform versions is we want to provide a reliable, consistent environment once you have deployed your applications in production. So no new feature changes. There may be features that do not need a lot of changes in the underlying infrastructure. In that case, we just make them available across all platform versions. But if there are any changes that have to happen, they go into a new version. We roll out a new platform version. For example, as part of platform version 1.2, we launch access to private registry authentication. So if you are using something that's not Amazon ECR, you can use that feature. That required some changes. We do, however, patch and update and manage the versions that are already out there for bug fixes and security fixes to make sure your environment is always secure. Now, so one thing I do want to note that tends to sometimes throw people off and I get questions on is the latest pointer that we have. So when you launch a service, you want to launch it on the latest because it has all the feature functionality, but it does not mean that by picking that, you will automatically be upgraded across versions. Let's just say, well, today, latest points to 1.2. When we launch 1.3, for example, you will not be moved automatically. You have control over when you want to move across versions. And the way to do it is, you don't have to change your application definition or your count of how many tasks you need. You do a sort of a forced deployment, and it triggers a new deployment to the 1.3, for example. So just wanted to clarify that. So for example, here, one way to think about it is, I want to test any new platform version in my beta cluster first. And by the way, these versions are only service specific, so it's not really a cluster setting. But you can make a directional decision to say, well, this is what the production traffic will run on, right? And your services can migrate and deploy to 1.2, and you can use the latest and greatest in beta to qualify, make sure things are working as expected before you move your production environment as well. So, with your platform versions, you can safely deploy across different environments. With respect to compliance, all ECS compliances apply to both Fargate and EC2 launch type. So ECS is compliant with SOC 123, PCI, HIPAA, and ISO. And we're also looking at some other compliances in the future. Happy to talk about that later. Some of our customers who have been using Fargate at scale in the year since we launched are over here. One of them is KPMG, and we're really fortunate to have them on stage. So I'll just hand it over to Ariane.
Thanks very much. Hi, everyone. Thanks for being here today. My name's Ariane Gadd. I'm a DevOps engineer at KPMG. Let's go on to my slide. So I'm going to be discussing with you today a use case whereby KPMG deployed microservices to AWS Fargate. We're going to be discussing how we took an existing solution already running in AWS, we redeveloped and re-architected that so that it could be microservices, which could be containerized, and then deployed out to AWS Fargate, and how we manage that CI/CD pipeline for deploying out the infrastructure and application. So we were looking at how we could take that existing solution in AWS, optimize it for scalability, resiliency, and elasticity for ease of deployment and management by migrating to microservices and containers. So a little bit about me and my role at KPMG. I work in a team called CloudOps in KPM in Solutions and Digital. I joined 4 years ago, and when I joined, there was only 3 of us in the team, with 1 project running in AWS. We're now up to nearly 100 engineers. We've got 250 production workloads, 90% of which are in AWS. We've also got another arm of CloudOps where we're actually going out to our clients and advising them on their business cloud strategies now. So we're delivering technology solutions to our clients and also advising on them on how they can build out in the cloud to meet regulations and compliance. We work across all sectors globally. So we have clients not just in the UK, but all over the world. So the main sector that we're working in at the moment is the financial services sector. The use case I'm going to discuss with you today is a bank, and most of our transformation projects are in the financial services sector, but we also have projects running with the government, civil service, retail sector, and also we've delivered solutions for our colleagues internally in the tax and audit functions at KPMG. So the solution that I'm going to discuss with you today. So 2 years ago, we built a customer due diligence solution for a global international bank. It's sort of know your customer type thing. It's about 24, 25 different applications, all integrated, running in AWS. It's been successfully running for the past, over the past year. And so recently, earlier this year, we sold it on to another large bank based in the UK. But we thought, how can we look at re-architecting this solution and redesign it so to optimize it for being in the cloud? The initial solution, whilst it's been running successfully, had a lot of pets. So we were having SQL Server 2008 running on EC2, which meant the need for database administrators, privileged access management to those servers, regular patching. So we wanted to look at how we could re-architect that so it would be immutable, scalable, highly available for the new project. So our developers redeveloped the application, the front end, to a number of microservices, which could then be containerized and run in AWS Elastic Container Service. So we went from running .NET C# code in Windows EC2 web servers to running with AWS Fargate and containerized with a mixture of Python, Node.js, .NET Core. We went from our existing CI/CD pipeline, which was TeamCity and Octopus Deploy, to deploying that .NET code out to Windows EC2 web servers, to using Docker and Jenkins. And finally, we were using CloudFormation as our infrastructure as code pipeline, and we moved from that to Terraform. And the reason for that is not because Terraform offered anything over and above CloudFormation, but the main reason being was because as we grew over the past 2 years to a much larger team, we needed to standardize our infrastructure as code pipeline. So we had multiple projects that were using all the same repository of Terraform code. And that allows us to put a set of security controls around every environment, so things such as AWS config, CloudTrail enabled in all regions, but also now we could take this solution and deploy that out to now we've built the Fargate modules, we can now deploy the same solution out to other clients. So this is the reference architecture that we came up with for our new customer due diligence solution. So underpinning the entire solution, we had a workflow management tool that was actually running on EC2 Linux, all in auto-scaling, highly available, but then the rest of it was running with ECS Fargate. So it's a number of different microservices, all one Fargate cluster. Each microservice is a different service, a different Fargate service. Some of them are talking to S3, some of them DynamoDB, all using ECS task execution roles with permissions out to those tables or buckets, and each of them behind an application load balancer as well. And we're using service discovery for the apps to talk to each other. Why did we go with ECS Fargate over EC2? We wanted to go for a managed container service, first of all, for immutability. We didn't want our developers or our administrators to be able to log into those servers. The cluster resource provisioning is all handled by AWS Fargate. We didn't have to manage the patching of the operating system, so the overheads from our team would be a lot lower. It also handles scalability, and all the security is managed by AWS. So there's a smaller surface area for attacks. So we've designed our solution, we've designed the reference architecture, how we want to deploy it, and our developers have started building out these microservices with Docker files in order for us to build out images that could be containerized. Then we had to start thinking about our path to production. How were we going to get from what we wanted to build from development into production and manage that CI/CD pipeline? We had a different AWS account for each environment. So one for development, for UAT, pre-production, production. And then we had separate AWS accounts for central services. We actually had two, one for production, one for non-production, and that was security reasons stipulated by the bank. And in those accounts, we had shared services by the environments, things such as the ECR repositories, which the images were deployed to, and then with permissions on those ECR repositories out to the relevant accounts. Other things such as Active Directory, Workspaces, SES, Route 53, and our Jenkins slaves were also sitting in those environments. So we had a Jenkins pipeline for CI/CD, which would, when the developers commit their code into a Bitbucket repository, the Jenkins job would be triggered. It would build that image, deploy that to the ECR repository in the central services account, and then that would trigger another step in the Jenkins pipeline, which would deploy that to the Fargate service relevant to the microservice using the ECS deploy CLI. For simplicity, we decided to go for two different pipelines, one for infrastructure deployment, one for application deployment. The top line is the infrastructure deployment pipeline. So when we commit our Terraform code to a Bitbucket repository, to the master branch, that would trigger the deployment of the Terraform code out to the environments. We're also using Vault for secret management. And then the bottom line is the application deployment, which is a Bitbucket repository. The developers would commit their code there, trigger a Jenkins job to build the Docker image, deploy that to ECR repository, which would then trigger that to be deployed to the ECS Fargate service in each environment. So now I'm going to actually show you what that looks like in Jenkins pipeline, what the actual code looked like. So it's written in Groovy, very simple pipeline, set of stages. This is a snippet from the first step of the pipeline, which is to pull a base image from the ECR repository. To pull a base image that it sits in our ECR repository, and all of our Docker files are built off that image. It then checks out the code that's been pushed to the Bitbucket repository by our developers, and then it builds the image and pushes that to the ECR repository. It tags this image with a Jenkins build number, so for versioning, so we can keep track of each release. And then the next step is to deploy that to Fargate. And we chose to go with the ECS deploy CLI, which is available on GitHub. The reason we didn't go with AWS CLI was because at the time of building this, it didn't allow us to update an individual property in a task definition. That meant we had to create a whole new task definition and then force update the service, which was actually 3 separate AWS CLI commands, which got a bit messy. But the ECS deploy allowed us to update just one property in the task definition. In this case, the image, the container name of the image, which is the latest revision that we've just deployed to our ECR repository, so with the tag of the build number. So just one very simple command. What that does is it updates the task definition, creates a new revision, and then automatically the service then picks up the new task definition, deploys a new container with the latest image, and once that's up and healthy, it will take down the previous version. Going back to our deployment pipeline. So we've just discussed the pipeline for the application deployment. However, in a minute, we're going to have a look at the task definition JSON, which is deployed by Terraform. And this has an image tag that's in that Terraform state file. So if we were to then go ahead and run our Terraform pipeline, it's going to roll back to the tag on that task definition JSON. And it was going to roll back our image to whatever that is, because that's what's within the state file. So we had conflicting pipelines here. We had to look at how we could manage this going forward. As we were starting to build more and more releases, we couldn't keep updating the Terraform each time. So looking at the task definition JSON, you can see here the image, the tag there is latest. So anything tagged as latest is what Terraform wants the image to be in your container. So if we're tagging it with that Jenkins build number as well, it's going to roll back when we run Terraform. What we did is I'm going to show you some snippets of our Terraform code now. We output a data source in our Fargate module, which output the task definition family of the microservice. And this meant that every time Terraform was run, the Fargate service resource would look for the most recently deployed revision of the task definition, rather than the task definition defined in the Terraform state file. Lastly, we had to think about how our services were going to talk to the relevant S3 buckets, DynamoDB, and each other. So this is back to our reference architecture looking here. You can see some of them are using different services with the roles defined. But we actually had to define environment variables in order for them to talk to each other. So for example, as you would with Docker or tag env, in Fargate you use environment variables. So looking back at the task definition JSON, you can see here we've defined in that template file the environment variables that we want that microservice to be talking to. And then in our Terraform resource module that gets deployed out as part of our infrastructure as code pipeline, we reference the template file, which is the task definition JSON file. And then we add there the required variables. So in this case, you've got the service discovery endpoint and an S3 bucket. And the good thing about this as well is we can actually reference other modules that were deployed as part of our Terraform infrastructure as code pipeline, because, so you can see here, it's looking for an S3 bucket as part of another module. So we don't have to run separate hard-coded S3 buckets here. We can reference that. So we wanted to deploy to Fargate. We've deployed all of our CI/CD pipelines. How did we convince the client, the bank, to go with Fargate and containers? Well, containers, the banks already understand the benefits of Docker for ease of deployment and scalability. We found that we were able to convince them Fargate integrates very well with the other AWS services that we were planning on using for them, so ECS, ECR. We could use the bank's existing tool sets and skill sets. So they were already using Jenkins and Bitbucket, so we could reuse that, and then therefore we can use the skills that they already had. We actually found that there was compared to running EC2 launch type, the cost of ownership was actually lower than EC2, ECS EC2 because of overheads like managing, patching, and so on. And obviously, the AWS stats speak for themselves. They've got the SLA and all those compliance controls there with Fargate, which actually worked out more secure for going with Fargate than with EC2, which was obviously a very big positive for the bank. Additionally, we had to put additional security controls on it, naturally. Fargate runs in your own VPC, so all the networking and subnets is controlled by you, so we could ensure that we were putting it in private subnets, we had those security group rules, we had that control over the networking. We have all of the microservices behind an application load balancer, which allows us to put AWS WAF in front of that with SSL terminating on the load balancers. We've got all logs enabled, and it's shipped to CloudWatch Logs, the integration with ECS Fargate and CloudWatch Logs. And we also use a third-party tool called Twistlock for container security, so we can create our own policies which ensure security right from the creation of that image to the deployed containerized microservices in Fargate. And finally, AWS manage the service, so we can be sure the security controls are in place at the server level with the automatic scalability to mitigate in the event of any attacks. So why did we go with AWS? Well, we've been using AWS now for 4 years, and we found that it allows us to significantly reduce our costs compared to running things on-premise. We're able to take advantage, as a team, wider team, we're able to take advantage of things like bring your own license with RDS and reserved instances. We found that we've already got our infrastructure as code there. We've already built it. We can deploy our environments incredibly quickly for new projects, taking existing solutions and deploying them to new clients. So the speed of delivery is much quicker. And finally, we've already got our existing CI/CD pipelines which lend themselves to AWS. So we're allowed to collaborate with our developers and have a DevOps culture, get that application code deployed quickly, iterate on that, and get out new iterations to our clients much faster. So what's the future for KPMG and AWS? Well, as I've mentioned, we've got 90% of our production workloads already in AWS. We're hosting banking clients' confidential data in AWS. We've got a growing team of certified engineers, so I would say most of our team have at least one AWS certification. We've got an alliance partnership with AWS. And as I mentioned before, we've been growing exponentially over the last 4 years, and there's no signs of that slowing down. So there's no signs of our usage of AWS slowing down either. Thank you very much all for listening. Any questions, then just come find us at the end. And please also give your feedback on the app. Thanks all for coming.